Welcome back to my Rogue Math series, in which I detail the story of ways in which I have been attempting to remediate some of the integral issues with some of the ways that we do basic math. Today I'm going to be focusing on vertical multiplication, or to be more general, multi-digit multiplication, that being multiplication involving numbers that are both 2 digits or more. Now, when students approach vertical multiplication, there have been two main issues that crop up. The first issue is that they just conflate the rules of vertical multiplication with those of vertical addition and subtraction. I have seen students lining up the decimal point when we start getting into numbers with decimal points. I've seen them adding extra zeros for the same reason. I have seen them even just multiplying vertically and calling it a day after that, which is very, very wrong. And on the other hand, I've also seen students, after they're introduced to vertical multiplication, have more doubts about their understanding of the rules of vertical addition and subtraction. So not only has the vertical way of doing things impacted their ability to do vertical multiplication, but it's also impacted retrospectively or retroactively their ability to do vertical addition and subtraction. So that was one of the main things that I was really focusing in on as a way to fix vertical multiplication, is just to make it not vertical anymore. The other big issue, and of course, every teacher has seen this one plenty of times. When it's time to make that second line, we're forgetting to put the placeholder 0. And it happens. But it is a thing that causes wrong answers a lot. So with these common issues in mind, I set out my goals for trying to reform vertical multiplication to make it better. And the first was simple: make it not vertical anymore. It needed to not look like vertical addition and subtraction anymore. And a simple cosmetic change to differentiate it would be enough, probably, to solve some of the major problems. But with that being said, I wanted to get a little bit more precise. I wanted to link it to area models, since area models have now become a pretty common way in which teachers teach the basic understandings of multi-digit multiplication before they get into the standard algorithm of vertical multiplication. So I wanted it to look more like area models. So that gave me a blueprint of this two-dimensional way that I wanted to approach things. I also wanted to, if possible, cue or at least facilitate remembering to add placeholder zeros to shift the place value for the lines where they need it. And the last thing I kept in mind was that, more than anything, I didn't want to overcomplicate the process, because, to be frank, vertical multiplication has a very good process. It's really speedy, it's really efficient, and I didn't want to mess with that, because I know that while it could be nice to teach something that's a little bit easier for learners, I also want it to be something that they could stick with throughout their lives doing mathematics, and not have it just be something transitional. So those are my goals. And so with those goals in mind, I started my development, and it took a few different tries before settling on something that wasn't too overcomplicated, but I think it worked out all right. But let's start with just a rehashing of area models as they are taught. So when we do an area model, what we're doing is we're breaking up each number into expanded form. So 325 turns into 300 plus 20 plus 5. And then we've got 40 plus 8. Now the key for an area model is that it's two-dimensional. So we've got one number on top, and then the other number goes on the side. And the key here is that that means that we now can create a grid. So we can create this grid in between the numbers, and we're now set up to easily multiply each place value number together. Since each of them is just a single digit number with some zeros attached, that makes for some easy mental multiplication. So 3 times 4 is 12, and then we just count how many zeros to add. We add 3 zeros. So we have 12,000 for that box. 20 times 40 is 800. 5 times 40 is 200. On the bottom, we've got 300 times 8, that's 2,400. 20 times 8 is 160. And 5 times 8 is 40. Now, that wasn't too hard, but it does take a little bit amount of time to expand everything out. And most importantly, it's not very conducive to decimals. It's only really good for whole numbers. Once you start getting into decimals, then things get a little weird with the area model. You'll want to have them be doing something closer to the standard algorithm by then, so that they don't have to think too hard about what the place values are for their decimal places. But of course, the final step of all this is that we have to add all of these together. So that's the real reason why area models don't last too long, is because you end up potentially having to add together a lot of numbers. And even if you're like me and you can do it pretty quickly, it can still be quite a painstaking and, most importantly, takes up a lot of space process. So if I am finishing this up, 9 plus 2 is 11, 11 plus 4 is 15, 16. There. I hope I did my addition right. That's a lot of numbers to add together. But I came out with 15,600 for 325 times 48. Now, what I wanted to do is make a way that looks kind of like that, but has the speed and the efficiency of the standard algorithm. So what I came up with is something that looks pretty similar, but without the expanded form. So I just have 325, and then the 48 I put on the side again. So notice how I'm already making it look visually more similar to the area model. But functionally, it's going to be identical to the standard algorithm, with only one small exception, which is when and where we put the placeholder 0. The big difference between vertical multiplication and this 2D frame is that the tens place is on top and then the ones place is below it. If we had a 3-digit number, it would be the hundreds place, then the tens place, then the ones place. So what makes this actually kind of good is that it forces, or at least encourages, the student, the person who's doing the multiplication, to put their placeholder 0 or zeros down first thing. So we can put down a placeholder 0 first thing. I always put a slash through my placeholder zeros to differentiate them from zeros that I get through multiplication. And then we can continue on from there. 5 times 4 is 20. 2 times 4 is 8, plus 2 is 10. 4 times 3 is 12, plus 1 is 13. 5 times 8 is 40. 8 times 2 is 16, plus 4 is 20. 8 times 3 is 24, plus 2 is 26. And once again, I end up with 15,600 for an answer. So I found this to be pretty fast and not really any longer to set up or attack than vertical multiplication. Now, in admission, this did take a little bit of time to get used to. It did take a little bit of time to get used to looking for the number on the side and making these connections, whereas when we were doing vertical multiplication, the numbers were close enough together that my eye didn't have to go as far. But I got used to it, and everyone can. It's not a big deal to do that. But if you're trying to think about doing this for yourself, try practicing it like 10 times. before you make a judgment call, because it does take several times to get used to your eye movement going back and forth like that between the two numbers. But the real nice thing about this is that since you've got the horizontal and the vertical, it's very clear, just like in a multiplication table, you're multiplying by what? And you're completing your line with the 4s, then you're completing your second line with the 8s. They're nice and lined up. Now, with that being said, I did also create a scaffolded version of this. So if you set it up again, I was thinking to myself, well, how do I make sure that they're adding in the placeholder zeros? And the way I came up with, at least for whole numbers, is I can tell them to write down 40 and 8 rather than just a 4 and an 8. And that serves as a reminder to them that this 0, and then I'd actually have them practice crossing out the 0 and sticking it onto the frame. And this could be a good way to remind them that they need a placeholder 0, and especially as they get into 3-digit numbers and so on, it can serve as a reminder of how many zeros to add to each line. This obviously would be a transitional thing that you'd want to eventually transition them out of and get to the quicker version, especially by the time that they get into decimals. But it was just a thought that I had for helping out with that. But speaking of which, what does it look like when we're dealing with 3 digits and decimals, and so on and so forth? So let's take, for example, 25.3 times 3.84. Just random numbers here. So if I'm setting it up for myself, I am just writing it out, 25.3, 3.84 vertically. And as usual, I'm disregarding the decimals. I'm not even really thinking of them. But I am setting up my placeholder zeros in advance. Now, since I've got 3 digits down on the side, I set myself up with 2 placeholder zeros on the first line, 1 placeholder 0 on the second line. And that is something that the students will just have to memorize. But it's not that hard to memorize this familiar pattern, as it goes from 1 and then out, and then you could out, and it forms a triangle shape every time. So I don't consider it to be that difficult of an idea. But once you have your placeholder zeros set up, then it's just like vertical multiplication. The process is identical. 3 times 3 is 9. 3 times 5 is 15. And then 3 times 2 plus 1 is 7. And so on and so forth. You get the picture. All right? So that's my not so vertical multiplication.